What is a generic? So generics are also known as parameterized types, and parameterized types allows us to specify on what data our class, interface, or method would work on. So let's say, for example, generics allows a class to to allows the same class to work on different types of data. So without the use of generics also, we could achieve that earlier to generics also by using, let's say, object class, because objects is an super class of every object in Java, right? So what's the difference does generics makes? So let's start by looking at an example where we don't use generic and try to store our data and see what are the problems in that. And here we see that I've already created a class main, and so what we'll do is we'll create another class. I've created a class non-gen. In that, we'll store a value in our object, and that's just an object ob. Let's create a constructor for that, and also we'll create a method that returns that object. Okay, now let's go ahead in the main method, and what we'll do is we'll just simply create the instance of this object, that is non-gen new non-gen, and we are storing a string into this, because we could, this is a type of object, we could store anything into that, right? Now let's say I want to get the type of the, let's say I want to get the value of that object back, right? Or ob of the value of ob. So how we'll do that is ng.ob, sorry, ng.get ob, and that would returns an object, and we can create a local variable that would give us an object. Now we don't want an object, we know that this is a string. What we can do is we can create a string here, and now this gives an error, right? Why? Because we need to cast it. This is returning a type of object. We need to cast that. So this is the first problem with working without generics, is that is the explicit typecasting, which we need to do as developer. This is a step we have to do with it ourselves. We will have to say string ng.geto. We'll see how generic solves that ahead in our next lectures. The second problem, and if we run this, this would work fine. It would, and there's no compilation error. We can also print that out. So if you want to print string, and that it would print, yeah, it prints hello, right? Now let's say what I do is I write this instead of an string. I say that this is an integer. Is it? I don't know, and I typecast it both ways to integer, right? Now see, the compiler does not give us an error. Here comes the problem. The compiler is not giving us a problem because as for the compiler, this is a returning an object. It does not know what the underlying object is, right? We as developer know that this is a string. So this is the second problem, that is the type safety error. So it's generic, how generic solves that, we'll see that also in that upcoming lecture. But I just wanted to give you an idea how generics will helps us, right? So there are two instances where generics generally helps us. First, we saw that it was with typecasting. We had to explicit typecast. Generics would solve that. And second, the generics, what they would solve is that they would allow us type safety at compilation time. Now, at what if we run this right now, we see that there's a runtime error, right? But if we would have used generics instead of that, we would never have faced this error. So let's go ahead and I'll create a generic example just for you right now. So what I do is I create a generic of object, right? Just to show you that, sorry, generic of what we don't normally use object, such long name for a generic. This you don't have to understand it for right now. Just look at that how that would change. So now we use t of this, and we'll just use gen here, and it would be of type t here also, this dot ob, and then this returns t. Okay, this is how a generic class looks like. You don't have to understand, we'll understand it further examples. I'll change it here also. I'll just change the name gen and gen. Now we'll see an warning here that this is a raw use of parameterized class. What we will do is we'll give this a parameter to work on. Since we are working on string right now, what we can do is we will have to write string here, and also we can just leave it like this, or we can write string. Both works. You can just leave it here since we are already writing it here. It doesn't make sense to write again. So now you see that as soon as I wrote this the compiler gives us error. It cannot cast string to integers. So this is how it solves the type safety error. And now let's say I remove this integer and I bring back the string again. You'll see that we don't have to explicitly typecast it as we did in our non-generic thing, right?